Hey all my family, welcome back to my channel. Today's tutorial is all about how to translate CSI ETABS analysis and design output into a constructible AutoCAD detailed drawing using Excel design template and AutoCAD program. At the end of this tutorial, you will know exactly how to calculate banded and distributed tendon spacing, how to decide number of strands within a tendon and that of the tendon profile. This is Excel design template to calculate spacing of banded and distributed tendon in X and Y direction respectively. We will discuss it in detail and I will share it if you are interested. Watch up to the end. Finally, I have a surprise to you. Now it's time for subscribe my channel, like this video and write your feeling on the comment section to motivate me for a further tutorial. Thank you. Let's start today's tutorial. This is a model file for a post-tension slab design folder to consecutive tutorial parts. That is tutorial part 1 and tutorial part 2. You can go and visit there. For today's tutorial purpose, let's go to select axis tool. This is the axis around this. And using this axis, we are going to interpret all outputs. So from this, for the banded tendon, we have 22 strands. So we are going to discuss how to put all these strands within a calculated value of spacing. So let's start. So to calculate all the spacing of the banded tendon, we are going to use Excel design template sheet. Let's open it. From this, the building code of standard, it's aero code and concrete grade is like this. The initial slab thickness, as you know, it's 200 millimeters. So the revised slab thickness, after designing all the punching shear and after check all the design checks in tutorial part 2, we are going to revise the slab thickness as 300 millimeter. And diameter of strand or tendon used, it's 50.7 millimeter square. The jacking stress is like this. And the banded tendon is in X direction and that of distributed tendon is in Y direction. This is the arrangement actually. From aero code standard, the typical strand per tendon is 3 up to 5. So in this case, we are going to use 3 strands in one tendon. Let's go to calculate the spacing of banded tendon in X direction. So from this, let's open ETABS output. From this axis to is actually this axis. So with a total number of 22 strands. So we are going to distribute this strands into tendon by calculating the tendon spacing. So let's go to return back to this Excel spreadsheet. Column and band widths, it's nothing but it's 25% of the shorter span, or you can use L over 4 to L over 3 spacing. I will show it in detail by opening the ETABS software. So you can take one of the two, that is 8 meter, 8 meter. So you can take the shorter span, but in our case it's equal. So banded width is L over 3 of this 8 meter plus L over 3 of this 8 meter. So let's return back to the Excel template sheet and calculate it. The column and band width is in millimeters, so you can calculate like this. So you can change 8 meter to millimeter, that is 800 millimeter divided by 3 times 2. You can get the column and band width. After calculating the column and band widths in millimeter, let's proceed to calculate the available widths, that is 10 centimeter or 100 millimeter edge clearance from the column and band widths. I will show the difference in AutoCAD software between that of column and band widths and available widths. So let's proceed to calculate the total number of strands. Total number of strands, this is 22, that is from ETABS output. So this is actually this output that mean. After deciding the total number of strands, that is 22 from ETABS output, let's proceed to calculate the total number of tendon with 3 strands. This is because aero code standard recommends that the total number of tendon must be 3 up to 5 for a constructability purpose. So let's proceed to calculate total number of tendon with 3 strands. So the total number of strand is 22 actually. From that 22 divided by 3, this is because total number of strand within one tendon is 3. So you can get total number of tendons. So we have 7.3, that is H tendon. After getting the tendon, let's proceed to calculate the tendon spacing. Tendon spacing is nothing but it's equal to available width, that is have gates, by subtracting 2 times the edge clearance from the column band width. So available width divided by total number of tendon. So we have get total number of tendon as h minus 1. So you can get the spacing. So the tendon spacing is calculated like this. After getting the tendon spacing, let's go to compare it with the minimum spacing of tendon and the maximum spacing of tendon. So EuroCode standard recommends that the minimum spacing of tendon is or must be greater than or equal to 4 times that of diameter of strand. So diameter of strand is 50.7 millimeter square. So the minimum spacing is 62.8. And that of the maximum spacing of tendon, the maximum spacing of tendon must be less than or equal to 6 times the slab thickness, that is the revised slab thickness. So 6 times 300 millimeter, you can get the maximum spacing of tendon. So from this, the provided spacing of tendon is 730 millimeter. That is good. This is because it's between the maximum and minimum value. After calculating the spacing of bundle tendon in x direction, that is the provided spacing of tendon as 730 millimeter, let's proceed to calculate the spacing of distributed tendon, that is tendon towards the y direction. As I told you before, the maximum spacing of a distributed tendon must be less than or equals to 1.5 times slab thickness. So in this case, have to use the revised slab thickness. So from this, the maximum spacing of distributed tendon is equals to 1.5 times 300 millimeter. So I have to get 450 millimeter spacing. In this case, I have to increase the slab thickness up to the ETABS output, or that of the distributed tendon must be 1 strand. I will show this point. So you have to increase the spacing of distributed tendon up to the distributed tendon value must be 1 strand. Up to this, you can increase the slab thickness. So from the ETABS output, the maximum spacing is the maximum provided spacing for distributed tendon is 600 millimeter. So using all this data for both the banded and the distributed tendon spacing, let's proceed to draw all the tendon, that is the tendon or the banded tendon toward this axis 2 on the AutoCAD software. This is all about the detailing toward this axis 2. So I will clarify all the points here. The yellow line indicates the column bandwidth, that is the column strip. So from the column strip, we have subtract both sides the 100 millimeter edge clearances to get available widths. This is a tendon with 3 strands. So this is a free end and this is a fixed end of our tendon. So from this, we are going to arrange all the tendon using the calculated value of spacing, that is 730. So all the tendon looks like this. The other very important point is that profiles of tendon. From this, I'm going to insert all the profile of tendon like this. This is actually the elevation and this is the distance. So let's go to the ETABS output and I will show how to get all this value in millimeters. So let's go to the ETABS output. So let's go to click on axis 2, that is the bundle tendon. After that, let's press the Control key and right click on this tendon. After that, I will get the tendon. So make it okay. From this, I will show how to get all the profiles of this span, that is around axis 2. So as an example, let's show from A to B. So from this is all about the profile distance A. So let's check the distance A, that is 0.8 meter from the center. So let's check it. 0.8 meter, that means 800 millimeter from the center. So this point and this point is 100 millimeter. I will show it. From this, let's take the profile as ZL, that is this is ZL value, that is 100 millimeters. So this point and this point is 100 millimeter. After that, starting from the center, we are going to proceed to see distances. So we have get ZC, that is the elevation or the profile. So ZC is actually ZC is actually this elevation. That means, so let's get this distance. What is this distance mean? That is C. So from this C is 4 meters. So from the center, that means, so let's go to the CAD file. So we have starting from the center, this plus this, 4 meters. So we'll get the profiles of this tendon as 40 millimeter. So let's check it. ZC value, that means ZC value 40 millimeter, that is. So you can calculate all the profile like this in similar way, that is for span 2, 3, span 4 and 5 respectively. This is all about today's tutorial. Let's proceed to our surprise point 1, 2, 3. Next tutorial is design together a mini stadium having inclined column, beam and slab. See you there. Thank you for watching. Goodbye.